Hello, good day everyone. Welcome to my channel. Uh, for this session, we are going to solve a problem on helical springs. So let us start with problem 343. Determine the maximum shearing stress and elongation in a helical spring, a steel spring composed of 20 turns of 20 mm diameter wire on a mean radius of 90 mm when the spring is supporting a load of 1.5 kilonewton. Use equation 3-10 and G being the modulus of rigidity equal to 83 gigapascals. So what is given here is a steel spring having 20 turns. The wire diameter is 20 mm and the mean radius of the helix is 90 mm. The load P is 1.5 kilonewton, which is equivalent to 1,500 newtons, and the modulus of rigidity is 83 times 10 to the 3 newton per mm squared. And we are going to use this equation 3-10. So we need to find the maximum shearing stress, tau max, and the elongation of the spring when it is loaded. Okay. So the first step is to determine and compute for this value of m. So we can, by the formula, m is equal to d mean diameter over the wire diameter. So the diameter is twice the radius, so 2 times 90 divided by the wire diameter, which is 20. So the answer for m is equal to 9. So that will be placed there. So tau max will have this formula. Substituting values, we have 16, P is equal to 1,500, R is equal to 90 divided by pi, and D is 20 cube times the quantity 4, M is 9 minus 1 divided by 4 times M, which is 9 minus 4 plus 0.615 over m, which is 9. So computing for this value, tau max is 99.874 megapascals. To compute for the deformation or elongation, we have this formula. Deformation delta is equal to 64 PR cube n over GD to the fourth. So deformation is equal to 64 times P, which is 1,500, times 90 cube times 20 divided by 83 times 10 to the 3, that is G, divided by D, which is 20 to the fourth. So the deformation will have the answer of 105.397 millimeters. So that will be the answers to the problem. So the next problem is problem 344. Determine the maximum shearing stress and elongation in a bronze helical spring composed of 20 turns of 1-inch diameter wire on a mean radius of 4 inches when the spring is supporting a load of 500 pounds. G is equal to 6 times 10 to the 6 psi. So what is given here is a spring which is loaded with 500 pounds, and now number of turns is 20, the wire diameter is 1 inch, and the mean radius of the helix is 4 inches. Load is 500 pounds, and the modulus of rigidity is equal to 6 times 10 to the 6 psi. And we are going to use equation 3-10. We need to find the maximum shearing stress and the deformation. Okay, so to do that, we first of all solve for m, and that is the mean helix diameter divided by the wire diameter. So D here is twice the radius over the wire diameter, which is 1. So m here is equal to 8. So we are going to use equation 3-10, and equation 3-10 for tau max is equal to 16 P times R over pi d cube times the quantity 4m minus 1 over 4m minus 4 plus 0.615 over m. So we substitute the values. So we start with 16. P is 500. R is 4 inches divided by pi. The diameter, wire diameter is 1 inch cube times 4. M is 8 minus 1 over 4 times 8 minus 4 plus 0.615 over m, which is 8. So if we are going to calculate this, the answer would be 12,060.31 psi. So that would be the answer for the maximum shearing stress. So the next part of the problem would be to solve for the deformation. So the deformation has the formula 64 p r cube n over g d to the fourth. So deformation is equal to 64. P here is 500. R is 4 cube. N is equal to 20 over g, which is 6 times 10 to the 6 times the diameter, which is 1 to the fourth. So deformation will be equal to 8.826 inches. So that would be the answer for the deformation. So the next problem is problem 345. So it's stated here that a helical spring is fabricated by wrapping wire 3/4 inch diameter around a forming cylinder 8 inches in diameter. Compute the number of turns required to permit an elongation of 4 inches without exceeding a shearing stress of 18 kSI. So use equation 3-9 and modulus of rigidity G equal to 12 times 10 to the 6 psi. So this is equation 3-9. So the diameter of the wire is 3/4 inch. The helix mean diameter is 8 inches. The allowable deformation is 4 inches. The maximum shearing stress is 18 kSI, or that would be equal to 18,000 psi. And the modulus of rigidity is 12 times 10 to the 6 psi. So find the number of turns for this spring. So in order to solve this problem, we need to use the formula tau is equal to 16 PR over pi d cube times 1 plus d over 4r. So that would be equation 3-9. So our tau here is actually 18,000 psi times 16. P is unknown. R there is half of 8, so that will be 4 over pi. Wire diameter is 3/4 raised to the third power. Then 1 plus wire diameter is 3/4 over 4 times R, which is half of 8 is 4. So if we are going to compute for P, the answer for P would be 356.066 pounds. So that is the load on the spring. So to compute for the deformation number of turns, we need to use the formula for deformation. 64 p r cube n over GD to the fourth. So the deformation is 4 inches is equal to 64. Our P is 356.066. Our R is half of 8, that would be 4 cube, and N is the unknown divided by G is 12 times 10 to the 6, and our D is 3/4 raised to the 4. So we are going to solve for N, and will come out to be 10.41 turns. So meaning the spring will have 10 turns and 41. It did not reach 11 turns. So that would be the answer to that problem. So the next problem is problem 346. Compute the maximum shearing stress developed in a phosphor bronze spring having a mean diameter of 200 millimeters and consisting of 24 turns of 20 millimeter diameter wire when the spring is stretched for 100 mm. Use equation 3-10 and a modulus of rigidity G is equal to 42 gigapascals. So what is given here is a phosphor bronze spring. The helix diameter is 200 mm and the number of turns is 24. The wire diameter is 20 mm and the deformation or the stretch delta is equal to 100 mm and G here is 42 gigapascals. So find the maximum shearing stress. So to solve that, we are going to first use the formula for deformation, which is equal to 64 PR cube N over GD to the fourth. Okay, so deformation is 100 equals 64. P is unknown. R, there is half of 200, so that would be 100 cube times N, which is 24, over G, which is 42 times 10 to the 3, times diameter, which is 20 raised to the 4th power. So we can solve for the load in the spring. The answer here is 437.5 newtons. So we need to find now the maximum shearing stress, and we are going to use equation 3-10. So the equation is stated here as tau max is equal to 16 PR over pi d cube times 4m minus 1 over 4m minus 4 plus 0.615 over m. So we need to compute for m. M here is d over d. So m is equal to d is 200 over wire diameter is 20. So m here is equal to 10. So substituting values, we have here 16. Our P is 437.5. The R is half of 200, so that would be 100 over pi. Our wire diameter is 20 cube times 4. M is 10 minus 1 over here 4 times 10 minus 4 plus 0.615 over m, which is 10. So computing for the value of tau max, so the answer here would be 31.886 megapascal. So this is now the answer to that problem, no, for what is required. So the next problem is problem 347. Two steel springs arranged in series, as shown here, supports a load of P. The upper spring has 12 turns of 25 mm diameter of a mean radius of 100 mm. The lower spring consists of 10 turns, so n sub 2 is 10, of 20 mm diameter wire, so that is d sub 2 equal to 20 mm diameter, on a mean radius of 75 mm, so R2 is equal to 75 mm. So this one is spring number 1, this one is spring number 2. If the maximum shearing stress in either spring must not exceed 200 megapascals, compute the maximum value of P and the total elongation of the assembly.